Your biggest security threat may not be a hacker breaking in. It may be an AI agent you authorized yesterday. Give that agent email access, a persistent token, and one trusted connection, and it can quietly reach far beyond the task you approved. I'm going to show you how that privilege chain forms, how prompt injection can weaponize it, how to trace the resulting data leaks, and the exact governance checklist that closes the back door without banning useful automation. The problem starts with a phrase that sounds harmless: AI productivity tool. An employee connects one to email, another connects one to cloud storage. A team gives an autonomous workflow access to an internal database or proprietary codebase. Each decision may look reasonable on its own. Together, they create a fragmented machine-to-machine permission system that nobody designed as a system. Traditional identity and access management was built around people. A person signs in. A person completes multi-factor authentication. A person gets a role. Autonomous agents operate differently. They run in the background, reuse persistent tokens, cross-connected services, and continue working after the person who approved them has moved on. That is why this requires more than checking a list of approved applications. First, we need to expose the illusion of control. Then we will map transitive trust. After that comes the dangerous twist. An authorized agent can become an automated insider without deciding to be malicious. Finally, I'll walk you through an audit and a least privilege framework you can actually apply. The first clue is hiding in how these tools get onboarded. Shadow AI rarely arrives with a dramatic security alert. It arrives through silent onboarding. An employee finds an AI tool that can summarize messages, organize files, or automate repetitive workflows. These tools ask for API access. The employee approves it because the requested connection appears related to the task. Productivity goes up. Nobody hears ominous music. The problem is that the employee may be authorizing broad read and write capabilities rather than one narrow action. The user thinks, I gave it access to summarize my email. The technical reality may be, this background service can continuously read messages, follow links, write data, and interact with other trusted systems. That gap between human intent and machine capability is the first shadow. Rapid adoption of autonomous agents in 2026 has outpaced identity frameworks designed around human users. The security perimeter is no longer one employee, one account, and one login. It is a web of services granting permissions to other services. Human-centric controls can show that the original user was legitimate. They do not, however, automatically prove that every later action taken through that user's authorization was appropriate. This creates an illusion of control. The dashboard shows a known employee and an approved connection, so everything looks tidy. Underneath, a machine identity may have access that is broader, longer-lived, and harder to observe than the person realizes. If you want to find Shadow AI, do not begin by asking who installed an application. Ask which machine can still act, what it can touch, and how long it can continue. That takes us from the visible approval to the invisible privilege chain. The key mechanism is transitive trust. Imagine an agent receives basic access to email. Inside those messages are links to shared cloud folders, automated reports, database notifications, internal support systems, and code repositories. If those connected services trust the same identity or accept actions through an existing integration, the agent can move from one authorized surface to another. It does not need to smash through every door. It follows the hallway you've already built. This is where multi-factor authentication can create false comfort. MFA protects an interactive login. A background agent may operate with a persistent token issued after that login. The person completes the challenge once. The token then allows the service to keep working without asking for fresh codes every time it reads, writes, or syncs data. MFA checked the badge at the front door. The token is already living in the building. To audit this properly, map permissions as a chain. Start with the human account. Record the agent connected to it. Record the token or service authorization that keeps the agent active. Then list every repository, storage location, database, and workflow reachable through that connection. For each destination, distinguish read access from write access. Reading can expose sensitive material. Writing can alter workflows, plant instructions, or move information into another system. Then compare that technical map with the original business request. If the request was summarize selected messages, but the map says continuously read an inbox and write into connected storage, you have found privilege drift. No trench coat required. The most important question is not whether each individual connection was allowed. It's whether the combined path was ever intended. And that combined path becomes far more dangerous when outside data can influence the agent's next action. Here's the twist that changes this from messy access management into an insider threat. The agent does not have to be malicious. It only has to process malicious instructions hidden inside external data. That is prompt injection. An agent reads a message, document, web page, or other input containing instructions designed to hijack its behavior. If the agent also holds trusted permissions, the hostile input can steer those permissions toward unauthorized activity or data exfiltration. The attacker is not necessarily defeating your identity controls directly. The attacker is influencing something your controls already trust. Your security system sees an authorized agent using an authorized token. The business sees automation doing its job. Meanwhile, the job itself may have been quietly rewritten. That is the birth of the automated insider: legitimate access, persistent presence, and actions driven by logic the organization did not intend. A traditional rogue insider is constrained by human behavior. A person sleeps, a person gets distracted, a person may hesitate, make an obvious mistake, or trigger suspicion by accessing systems at unusual speeds. A compromised or poorly configured agent has a different profile. It can operate continuously. It can search connected systems at machine speed. It can repeat the same action across every accessible repository without boredom, judgment, or a sudden attack of conscience. That cold efficiency is what makes the threat distinct. The agent can map which resources are reachable, collect sensitive material, and keep syncing as long as its token remains valid. Persistence is built into the workflow. High velocity is marketed as a feature. Broad connectivity is often the reason the tool was purchased. The dangerous properties are not exotic additions. They are useful properties pointed in the wrong direction. This is why looking only for stereotypical malicious behavior can fail. The agent may be using expected APIs. It may be connecting from an expected service. It may be acting under the identity of an authorized employee. Every individual event can appear normal, while the total pattern is unacceptable. So the audit has to shift from, was this login valid? To, was this sequence of machine actions necessary for the assigned task? That is a harder question, but it reveals the threat. An agent that needs one document should not enumerate an entire repository. An agent completing a temporary task should not retain permanent access. An agent that summarizes information should not gain unexplained write paths into other systems. Once you judge behavior against the task, the automated insider stops being invisible. Now we need the evidence trail. To trace shadow AI, build the audit around active behavior, not just an application inventory. First, identify every agent currently syncing with private repositories, cloud storage, internal databases, email systems, and proprietary code bases. Currently matters. An old approval may still support a live background process. Second, map the data flow in both directions. What does the agent read? What can it write? Which metadata does it send back to a parent model? A workflow may not appear to copy an entire confidential file, yet metadata about names, locations, activity, or relationships can still create legal and compliance problems. The audit must follow the flow, not merely inspect the file type. Third, find the shadow logs. Legacy security tools may record the employee's original authentication while missing the later machine-to-machine activity that used a persistent token. Look for records tied to token use, API calls, synchronization events, repository access, and agent actions. The goal is to connect those fragments into one timeline. User approved agent, agent received persistent access, agent reached service, service exposed repository, agent read or wrote data, data or metadata moved to another destination. That timeline turns a vague concern into something you can actually investigate. Fourth, compare activity with the stated task. If an agent was approved to summarize a defined set of messages, why is it touching cloud storage? If it was approved to organize one project, why is it syncing an entire codebase? The mismatch is your signal. Finally, test revocation. Remove the permissions and confirm that every related token, integration, and background process actually stops. A button that says disconnect is comforting. Evidence that the agent can no longer act is better. This audit does not begin with an assumption that every AI tool is hostile. It begins with the less dramatic and more useful assumption that unobserved permissions eventually become unmanaged permissions. Once the data flow is visible, governance becomes possible. The solution is not to pretend autonomous agents are ordinary employees, and it is not to ban every useful tool. The solution is least privilege designed for AI. Start with dynamic, time-bound tokens. An agent should receive only the access required for its current task, and that access should expire when the task ends. Temporary work deserves temporary permissions. Next, maintain a real-time AI inventory. Record which agents are active, who authorized them, which systems they can reach, whether they can read or write, what tokens keep them running, and when those permissions should be revoked. An annual spreadsheet is not real-time governance. It is archaeology with nicer column headings. Then separate high-risk permissions. Email access should not silently become storage access. Storage access should not automatically create a path into internal databases. Every transition needs an explicit business reason and an observable control. Monitor agent activity against the task it was assigned. Broad enumeration, unexpected synchronization, unexplained write activity, or access that continues after the completion should trigger review. Include prompt injection in the threat model. External data must be treated as potentially hostile when an agent can turn that data into privileged action. Finally, make revocation part of the workflow, not a cleanup project. When the task ends, revoke the token. When the employee changes roles, reevaluate the agent. When the tool is no longer approved, remove its connections and verify that background activity stops. The standard is simple. No agent should retain more access for more time across more systems than its task requires. That is how humans and agents collaborate without creating a collection of permanent and visible backdoors. So here's the full test. Identify the agent. Trace the human authorization. Map every transitive permission. Inspect persistent tokens. Compare read and write access with the actual task. Follow data and metadata to their destinations. Connect the shadow logs. Test prompt injection exposure. Then revoke anything that is too broad, too permanent, or no longer necessary. Shadow AI is not invisible because it leaves no evidence. It is invisible because most organizations are still looking for human-shaped threats. Change the map, and the backdoor appears. If this framework gave you a clearer way to audit autonomous access, please subscribe. Then watch my breakdown of prompt injection, where I show how ordinary external data can redirect a trusted AI workflow. That is the next layer to secure because controlling permissions only works when you also control what can influence them. Thank you for watching. Please like and subscribe, and we'll see you on the next one.